All right, Math 2, Unit 6, surface area. So I've already got some things written here. Surface area, I'm looking right here, is the area of the bases plus the area of the faces. So all we do with surface area is we kind of look at each side of the shape and we find the area and we add it up. Normally, what we call a base is whatever the shape is sitting on. So if you think of pyramids, the square that's on the bottom of the pyramid would be called its base. And the face would be each of the triangles on the side of it. So you can kind of imagine that a lot of these shapes, like especially pyramids, you can just kind of take those apart in your head and we can find the area of the triangles and we can find the area of the square. But some shapes need a special formula. So I've got three special formulas down here. We've got a cone. The surface area of a cone is pi r squared plus pi r L, where L is the slant height. So we look at this pi r squared, well, that's the area of a circle. And then pi r L, I don't have a really good way of explaining that one, but if you take a cone, cones like that, and you unwrap it, you're going to have a circle, and you're going to have a piece that looks something like that. This is where L goes, and there's your R, like how you know. So this would be the pi r squared piece, and this would be the pi r L piece. All right. A cylinder. A cylinder, we've got 2 pi r squared and 2 pi r h. So for starters, here's pi r squared, that's a circle, and then we've got two of them, because if you think of a can of soup, you've got two circles on the can of soup. Now you also have the side of the can, the piece that's kind of curved. H, you can kind of imagine where the H would be if we had our can of soup. Here would be our H, here would be our R. The 2 pi r piece would be the distance around it, like that. It's the circumference of the circle. If we thought about this, we would unwrap this can of soup. We have two circles and a rectangle. There would be our H. This is 2 pi r because it's the circumference of the circle. All right. And last up, we have the sphere. The surface area for a sphere is 4 pi r squared. And I don't have a really good way to know that one. That one's one that you just kind of have to memorize. All right, so those are our formulas. I think you'll find that the ones that need a formula are actually a little bit easier, because, or at least they're faster, because you just kind of plug it in, you type it in the calculator, and you're done. For the ones that we don't have a formula for, we're going to, or the way that I do them, is I draw little shapes, and I kind of take it apart in my mind, and then we find the area of the shapes. So let's start off with number 2. So we're finding the surface area, and if we have a decimal, we need to round to the 100th, which is 2 decimal points. So this shape here is a rectangular prism. It's a prism because every time you slice it, you would get the same shape. So like if I took a knife and I cut it here and here and here and here, think of a block of cheese. You're cutting the block of cheese, and as long as you're a decent cutter, you have a rectangle each time. So that's the same way here. This is our big block of cheese, and we're cutting slices out of it. A prism is just a shape where you slice it, you get the same shape each time. So we can kind of think about this guy here, and we have a rectangle on the front here, and it has a counterpoint or a counterpart in the back here. So we have two, that's the way I show that, two rectangles that are blue, and I want to write the dimensions down for them. I believe they're going to be a 2 by 1. Next up, let's find another set of rectangles. Let's do the one that's kind of facing the back and the one that's facing the front. So we have two more rectangles. And what are their dimensions? On the top, on the one that's kind of looking up, I can kind of see that it's a 5 by 1. Right. And this 5 here would also go right here for this side as well. And that one if you wanted to draw that in. All right, last up, we have one more set of rectangles. Where are they? I guess it's kind of this one here. It's kind of harder to see with all those drawings on it. That's kind of hard to see. But it's kind of like the one that's facing, I guess, up and down. So you have two more rectangles. And I think it's kind of easy to see if we look at the top one that it's a 5 by 2 or a 2 by 5, however you want to think about that. So I write those 2's there, the circled 2's, to remind me that I need to have 2 of them. So whatever I have the area of that, I need to multiply by 2. So the way that I do this is that I like to use my calculator, so I just write a big old long string of numbers and then I can type them in. So I'm going to start with my blue one. I have 2 rectangles, so I'm going to do 2 and then parentheses, and I'm going to write in my area formula. The area formula for a rectangle is 1 times 2, or base times height. And then for the orange one, I have 2 again. It's going to be 1 times 5. And then for the light blue one, it's going to be 2 of them, and it's 2 times 5. All right. If I type that in my calculator, we get 2 times 2 plus 10 plus, is that 20? We get 34. And our units are going to be yards squared. Just like whenever we do regular area, it's squared because this is just fancy area, right? We're not doing volume, we're still doing area. We're thinking about, one way to think about this is you take a shape and you paint the outside of it, and you're measuring how much paint would you use, right? Because you're painting the surface area of it. All right, that's number 2. Number 3, here we have a triangular pyramid. It's a pyramid because they all come up to a point. It's triangular because it has a triangle on its bottom, or on its base. So for starters, let's look at this triangle that's on the base. We only have one of those. I'm going to look at the base of the base triangle. Sometimes our words get kind of mixed up here. Is 4, and the height is 3.5. Now, we need to decide, are these all equal triangles? And if we look here, we get a 4 here, a 4 here, and a 4 here. So each triangle has the same base, and right here is our height. So we're going to have three triangles with a base of 4 and a height of 4.2. So now I've got all my sides and I'm ready to write my equation. So the equation for a triangle is 1/2 base times height. And now I need my green triangle. I have 3 of these. 1/2 base times height. Right. And for this one, I'm just going to type this into my calculator. So I'm going to have 0.5 times 4 times 3.5 plus 3 times 0.5 times 4 times 4.2. And I got 32.2 as my answer. My units are miles and they are squared. All right, let me draw this in. There's one of our side triangles. All right. Number 4, here we have a rectangular pyramid, right? It's a pyramid because they all come to a point. It's a rectangle because the bottom is a rectangle. Right. So I've already drawn in that rectangle. We'll draw it here. We only have one of those. The dimensions of it are a 1/2. And then if we look, we're actually going to have 2 different sizes of triangles here, right? We have the triangle here, and we're going to have the triangle here, if I can draw that in, right? And we can see that the blue triangle has another one on the back, and the orange triangle has another one on the back. So let's draw those in. We'll have 2 orange triangles. Their base is 1, their height is 3.2. And then for the blue one, we also have 2 of those. Their base is 2, and their height is 3. Right? And I don't normally take a whole lot of time drawing these shapes. They're just for you to be able to do your area formula. So don't try to be super pretty about them. All right, now for our area formulas, we'll start off with our rectangle base. We're going to have 1 times 2, and then we'll do the orange triangles. We have 2, 1/2, 1 times 3.2. And then we have our blue triangles. We have 2 times 1/2, 2 times 3. All right, and I'm going to just type this in. I'm going to have 2 plus 3.2 plus 6. I did a little bit of the simplifying in my head there. And I got 11.2, and we're talking about kilometers. They are squared. All right, that's that. Next up, number 5. These are normally the problems that people have trouble with. The trapezoidal prisms, right? It's a prism because we could think about if we sliced it there, or I guess it would be more like along it, like that. If you slice that, you get a trapezoid, and every time you slice it, you get a trapezoid. Another way to think about a prism is that if you put it between like one of those pressing videos that you see online where they like have things oozing out and whatnot, if you put this under there and you smashed it really hard, you'd just end up with a trapezoid. The trapezoid in the back and the front would end up touching if you smashed them really hard. Right? So we have 2 trapezoids. I'm going to draw in the bases here, and the height is right here. It is 1.7. Now, we have 4 different rectangles around it, but if we look here, this guy and this guy are actually equal. So we have 2 of them. Their dimensions are 2 by 2. If we look at the top rectangle, we have one of them. He is a 2 by 5. And the bottom rectangle, we have one of them, and he is a, what is he? A 3 by 2? Yeah. All right. Now we're ready to write our equation. So I'll start off with my trapezoid. I have 2 of them, and then it's going to be 1/2. The base is added together, 5 plus 3 times 1.7. The orange rectangle, I just have, I have 2 of those, 2 times 2. The green rectangle, 5 times 2. And the blue rectangle, 3 times 2. All right. So whenever I type this in, I am not going to do the 2 times 1/2. I'm just going to cancel those out. So I have 5 plus 3 times 1.7. And I put those in parentheses, right? Plus 2 cubed plus 10 plus 6. And I got 37.6. 37.6. And we're talking about inches, and they are squared. All right. Number 6, here we have a cylinder. It gives us our radius. Sometimes they'll give you the diameter, and you need to remember to cancel that out to the radius. And here's our height. The formula that I'm going to write here for us, surface area equals 2 pi r squared plus 2 pi r h. Now sometimes on problems like this, it will tell you to leave in terms of pi. So I'm first going to leave it in terms of pi, which means that you treat your pi like it's a variable that you can't multiply out. So I'm going to leave my pi in my answer for the first part, and then I'll multiply it out and get my decimal answer. Right? So I'm just going to plug this in. I'm going to have 2 pi 10 squared plus 2 pi 10 times 8. So again, I'm going to treat my pi like it's a variable to start off with. So I got 200 pi plus 160 pi, which gives me 360 pi. And we're talking about inches squared. So if it tells you to leave it in terms of pi, that would be your answer. But since our answer wants a decimal, I'm going to type in 360 times pi into my calculator. And I get 1130.2. 0.97. We're talking about inches. So don't forget that this is something that you can do, and I believe some of the homework assignments will ask you to do it that way. That would be considered the more precise way to do this problem, because the pi, you always have to round if you use pi, right? There's no way to round it perfectly or to give a perfect answer. All right, number 7. This shape is a triangular prism. We can see the triangle on the front here and in the back. So we have 2 triangles, and we can see because of that right angle that they are a right triangle. Our base is 3 and our height is 4. That 5 would be our hypotenuse. And then we have 3 different rectangles. We have this one in the back. So we have one of these guys. He is a 2 by 4. We have the one that's facing, facing the right. That's a 2 by 5. There's only one of those. And last up, we have this bottom one, which is a 2 by 3, right? This 2 here corresponds with this side and this side also. So this is a 2 by 3. So now we need to write out our equation. So we're going to have 2 triangles, 2 times 1/2, 4 times 3, plus 2 times 4, plus 2 times 5, plus 2 times 3. So 12 plus 8 plus 10 plus 6. That gives me 20 plus 16, which is 36, and we're talking about yards squared. All right, that's number 7. Number 8, here we have a rectangular pyramid. We'll start off with our base. I'll draw it orange. There's our base. So we have one of these. This is a 6 by 9. And then we've got our green triangle, which I'm going to say kind of faces the right there. And then I'm going to have a blue triangle also, which kind of faces towards the left. So I have 2 green triangles. Their base is 9. Their height is 9.5. And I have 2 blue triangles. Their base is 6. And their height is 10.1. Now for my formulas, I have 6 times, well here, I'll do that in the correct colors. 6 times 9 plus 2 times 1/2, 9 times 9.5, plus 2 times 1/2 times 6 times 10.1. Now whenever I write these in, or whenever I type these in, I'm going to cancel out those 2 and the half. Makes it a little bit faster. So I'm going to have 6 times 9 plus 9 times 9.5 plus 6 times 10.1. And I got 200.1. And we're talking about centimeters squared. All right, number 9. This is a cone. Surface area for a cone is pi r squared plus pi r L. And this is a really easy one. You just get to plug in. Here's our R, here's our L. So we have pi times 1 squared plus pi times 1 times 4.1. Now, like the last one that had pi, I think that was number 6, I want to leave this in terms of pi for starters. So I'm going to have pi plus 4.1 pi. That's 5.1 pi, right, because there's an understood 1. And that would be inches squared. And we could leave it like that. But since it asks to have it as a decimal, I'm going to multiply 5.1 times 5, and I get 16.02 inches squared. All right, that's number 9. Okay, number 10, here we have a sphere. Surface area of a sphere is 4 pi r squared. So really easy to plug in. 4 pi 4 squared. What is 4 cubed? That's 64 pi. meters squared. So that would be in terms of pi. And then if we multiply that out, we get 201.06 meters squared. The only thing confusing about the sphere problems is that sometimes it will give you the diameter, right? You got to make sure that it does not go all the way across there. You want it to just go across half. All right, last one, another trapezoid problem, just because those seem to be ones that people have trouble with. So I'm going to start off with the trapezoid. I have two of those. Right, and I can write in the pieces of it. Now I'm going to do this side here, along with this side here. And almost all trapezoidal prisms will have the same shapes on those sides, or they'll have congruent shapes on those sides. They won't be a square normally, though. The last one was a square. These are rectangles here. So you have two rectangles, and they are 6 by 8. One more thing, I can know that they're equal because I have the 6 and it has the tally mark there, and I've got tally marks on all of those also. All right, now I want to do the top shape, the top rectangle. This is a 10 by 8, and the bottom one, which is a 4 by 8. All right, so to write things in, I have two trapezoids, 1/2 10 plus 4 times 5.2 plus 2 times 8 times 6 plus 10 times 8 plus 4 times 8. It's supposed to be a times there. All right, whenever I type that in, I'm going to cancel out the 2.5 there. So I'm going to have parentheses, or I could just type that in as 14 times 5.2 plus 2 times 8 times 6 plus 10 times 8 plus 4 times 8. And I got 280.8. And we're talking about kilometers, and they are squared. All right, that is surface area.